Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at 3 index laws. So before we begin, we need to get some terminology down pat. You've probably seen something like this before. We read it as 3 to the power of 5. The number that's written larger is called the base, and this number that's written smaller is called the index or the power. So we know that 3 to the power of 5, when you're raising a number to a power, it means you multiply the base by itself this many times. So 3 to the power of 5 means you multiply 3 by itself 5 times. So we call this form index form because it's got an index, and we call this expanded form. So it's really important to understand that, because as I go through the index laws, I'm going to talk about bases and indices all the time. And you need to know what index form means, because the majority of the questions when you're studying index law will say give your answer in index form. So if you're asked to give your answer in index form, it just means something to the power of something. So let's look now at what happens if I do something to this 3 to the power of 5. So what if I multiply this by 3 to the power of 4? So I've got 3 to the power of 5, and I'm going to multiply it by 3 to the power of 4. So what you can see now is that I have 9 3s. 3 is being multiplied by itself 9 times. So in index form, this would be 3 to the power of 9. So hopefully you can see that rather than write out this long expanded form, there's a quick way I could have arrived at my answer. If I have the same bases, so 3 is the base in both of them, I just add the indices. 5 plus 4 equals 9. So what about when dividing? Let's say I have 3 to the power of 5 divided by 3 to the power of 4. So then I just need to put 4 3s on the bottom. Now, when you have a fraction or a division, you can cancel out things that appear on the top and the bottom. I can cancel as long as I do the same to the top as I do to the bottom. So I can cross out a 3 on the top as long as I do it to the bottom. I can cross out another 3 on the bottom as long as I do it to the top, and so on. You can see I'm just left with 1 3. Remember, 3 is the same as 3 to the power of 1, just like 4 is the same as 4 to the power of 1. So hopefully, again, you can see the quick way to arrive at the answer. If you are dividing bases, you simply subtract the powers. 5 minus 4 equals 1. So they are the first 2 index laws we need to know. So the index laws, when you multiply the bases, you add the powers or indices. When you divide bases, you subtract the indices. Let's apply this to a few questions. So if I have 3 to the power of 6 times 3 to the power of 2, I keep the same base and add the powers. So remember, fraction line here means divide. 12 to the power of 9, divide 12 to the power of 3. Keep the same base. This time I subtract the powers. If it works for numbers, it'll also work for pronumerals or letters. So for x to the power of 7 times x to the power of 3, keep the same base, add the powers. So when doing this one, y to the power of 8 divided by y, you do keep the same base. But remember, y is the same as y to the power of 1. So here I'm going to subtract the powers. It's 8 minus 1, which gives us 7. Now, sometimes you'll have numbers and indices and pronumerals to make things a little more complicated. We just have to understand what's a base and what's a power. So 4 and 7 are indices or powers. 3 and 5 are bases. So we're not going to add 3 and 5 because they're bases. We add indices, we don't add bases. So we're just going to do the numbers and pronumerals separate. 3 times 5 is 15. X to the power of 4 times x to the power of 7. Keep the same base, add the powers. So similarly for this one down here, 27 over 18, or 27 divide 18, we're going to do the numbers separately. 27 over 18 is 3 over 2. You can use your calculator if you need help simplifying. And then we go y to the power of 5, divide y to the power of 2. So keep the same base, subtract the powers, and we're done. All right, let's now look at the third index law. So let's look at 2 to the power of 4 squared. When you're squaring something, you're just timesing it by itself. So this is 2 to the power of 4 multiplied by 2 to the power of 4, multiplied by itself. So you can see clearly here there are 8 2's being multiplied. So in index form, that's 2 to the power of 8. Once again, there was a quick way to arrive at the answer. If you're raising a power to another power, you keep the same base and simply multiply the powers. 4 times 2 is 8. And that's what this says here. Power to another power, keep the same base, and multiply the powers. Remember, BC in algebra means B times C. So 3 to the power of 5 to the power of 4, you simply keep the same base and multiply the powers. X to the power of 8 to the power of 9, you simply keep the same base and multiply the powers. All right, we are now going to look at an example that involves using multiple index laws in the same question. So here we have something that looks quite complicated. We're going to simplify and give our answer in index form. We're just going to do it bit by bit. So let's start off with the brackets. So x to the power of 2 to the power of 3 is x to the power of 6. Now this 2 is not inside the brackets. It's not being raised to the power of 3, so I'm going to leave it alone. And I'm going to leave the x to the power of 5 alone for now. So hopefully you remember when you're dividing a fraction, you simply flip the second fraction. So I'm going to switch the numerator and denominator. And after you flipped the second fraction, you make it 8 times. So now we have one more bracket to expand. So I'm going to expand this one. So once again, the 4 is not being raised to the power. So leave the 4 alone. And power to a power, you keep the same base and multiply the powers. So when you're multiplying fractions, it's pretty easy. You just multiply the tops, multiply the bottoms. So 2x6 times x to the power of 20. I'll leave the number alone, keep the same base, add the powers. On the bottom, I'll leave the number alone, keep the same base, add the powers. So now I need to simplify this. So 2 over 4 just gives us a half. And to simplify the x's, we're now dividing, so we keep the same base and subtract the powers. So half x to the power of 9 is fine. You might also see it written like this. These two are the same thing. So when you have a question like this involving multiple index laws, don't panic, just do it bit by bit. All right, let's go to a summary of what we've learned. So we reviewed that when you have something like this, we're multiplying this number by itself this many times. This larger written thing is the base, and what's written smaller at the top is called the index or the power. Indices are just the plural of index. We're looking at index laws, so we're looking at laws involving powers. The first law says that if you multiply the bases, you add the indices. The second law says if you divide the bases, you subtract the indices or powers. Remember, division can be written like this or this. And then the third index law says if you have a power to another power, keep the same base and multiply the powers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.